I'm very pleased that I can speak in front of you, but also listen to your talks, and that we all come together here. I think it's something that, just fits perfectly to this place, but also that really is needed here. That, we find people that we can exchange with our ideas and things that we collected during the past years, and also like continue building this network that we've been doing for 5 years. So your talks that I could listen to were amazing and like really inspiring, and I'm really pleased to meet you all, also in person later. Jakob already introduced me, so I don't have to do that myself so much anymore. I'm an artist and musician, composer, and I studied composition, which is now, I think, about 8 years ago. And that's not where I met Paul, who's there, but we met like way longer back. But we have a kind of special relationship in what we are doing together, and also the software that I'm going to. You can also take the iPad. So I want to talk about a software that we've been developing for the last, I think now it's about 8 years. So the foundation was grounded when we were still studying together. And it kind of fusions both of our artistic ideas that are connected with spatial audio. So we work a lot with spatial audio and multi-channel systems and site-specific sound installations. Maybe you've seen some examples yesterday in site-specific sound installations that are very much connected to the space and the acoustics of the space. And we design also really different kind of multi-channel systems, use these kind of standardized systems, but also go far beyond that. I will show work at the end of my talk for an example how we actually use our software, but then we are also playing as musicians, and we are composing together for making music together, but also for different formats, opera, theater, and radio plays, for example, or video. And I'm saying this because we are using our software for all of these areas, and for us it's really a kind of multi-purpose composition tool, performance tool. But the idea came from the need to have a tool that we can do live performance on in multi-channel and in spatial audio. And I think if we would have known 4D sound 8 years ago, I don't know if it existed, but probably then maybe we wouldn't have started doing this, but I'm sure that we learned a lot from exploring this and really found a unique approach, I think, and a software implementation that can grow also, and that is also part of the idea. At the moment it's not released, but we are actually planning to open it in the future, and it shouldn't take that long. Okay, now it already seems like I finished my talk, but I just started. So it's called LEMM3D, and okay, how do you do this actually? I don't know anything about sound. LEMM3D. Yeah, okay. Don't want to blow your ears. So LEMM3D, it's a short for live electronic multi-channel mixer. So there's the first approach. We are doing live electronic music with it. We are addressing multiple channels, multiple speakers, and the kind of basic idea derives from a mixer. So it's like the most simple form of audio controller. I think everyone knows it. So but of course it has a special twist to it. So here you see a short screenshot. That is maybe if you worked hours in LEMM3D, then your desktop can look like this. When we are releasing it, then the GUI will all be more refined, but here you see that it's really it's a playground for spatial audio, and it's a whole collection of tools for multi-channel use. And yeah, the core idea basically, also as Paul said, I think there's many similarities, is that we perceive space as musicians, we perceive it as an instrument basically, and so there's, technically speaking, and in the implementation, there's a seamless combination of the sound synthesis and sound processing and the spatialization aspect. And of course, I will show the demo, but this means practically that, of course, we still have these two layers sometimes where we position objects in the space and are shaping our sound. But in many of the synthesis tools that we implemented here, the spatialization is already kind of thought inside of the spatialization, inside of the synthesis. And yeah, I will show you what I mean by this. But instrument also, of course, means that we want to be able to play it intuitively. We want to be able to be expressive on it, and also in our practice we are improvising a lot. So we don't want to spend hours and hours to prepare our set, which of course sometimes we have to do it, but we can go like from zero to a full capable set for playing a full set in a couple of minutes. And that is really the idea, that all the like complicated things that you have to think about when you're doing spatial audio, like we're doing now, it seems very easy, but many channels are going from one machine to the other, mixing somewhere, and until they're here on the speaker system, and all of this is automated in LEMM, so you don't have to deal with it like even once if you don't want to. So okay, yeah. So as I said, we're using it in a lot of different applications. So mainly we are using it as a live music tool, but also for sound design, composition, and also you can use it just for live mixing. So we've implemented it and used it here in several shows with instruments and small bands or ensembles, and it's an interesting tool also to kind of enhance the mixing capabilities with spatial audio reverbs, but also going more crazy with sound processing, different kind of multi-channel delays, granular synthesis and resonators and all of this kind of things. But also, if you don't want to use any of this crazy processing that is inside of the software, you can still use it as a quite fast and intuitive tool for spatialization. Yeah. So there's some core ideas that are underlying the software, which is, as I said, we want to have a simple interface because we wanted to be able to really, really start working very fast on the music and not so much in the technical setup. This we did already before by making the software, so now we don't have to do it anymore. And yeah, this also combines with a very quick setup of your set. This also connects to very intuitive MIDI mapping, which I mean, MIDI mapping in general is not so crazy maybe, but if you think about it, and if you just add like a couple more ingredients to the standard way softwares do MIDI mapping, then this can become like a very powerful instrument, because in the end, we are dealing, I mean, in spatial audio, but also in any kind of digital expression. I think we are always dealing with a very high amount of complexity. So we have like huge data sets that are running in the background for the spatialization. We have like all the position data, and also like all the parameters of the synthesizers and of the processing of all the effects. So there's a huge like data set that we have to control live somehow, and of course the way to make it possible to actually control it is to kind of reduce the complexity and make kind of macro mappings and kind of combine different kind of controls. And so there's also some some ideas that we thought about this a lot, and I think I think it's important for an instrument in the end, and there's some examples for that also, more concrete maybe. So as I said, so we don't think about routing in the software. It's I mean, we can of course change the standard ways the software is routing things, but in the end it's doing it by its own if we let it do it, if we want to keep it that way. And so like all this complexity that is connected with this, we don't have to know about it if we don't want to. Then our approach to spatial audio really changed with the possibilities that we saw while making the software. So when we started with composing spatial audio pieces, we positioned individual sound objects in the space and kind of tried to translate a standard way of music creation that is dealing with like mono or stereo signals, kind of translating this to spatial audio and being able to actually go at the core of a software and really just dreaming about how we would like to use, you know, the amazing possibilities of multi-channel speaker systems. We gain kind of another perspective to this is more like more architectural, more sculptural. So in many cases, we are not thinking about individual positioning, but we are thinking more in terms of like mass, like a kind of sound masses or sound like clouds of sound. Or if you think about like musical terms like texture, for example, we not only think about the acoustic quality of a texture, but we think about the spatial quality of the texture and how this can connect also to movement in the space, and really intertwining these two layers. So sometimes we are dealing with very, very high channel counts because the kind of clouds that we want to create, they need 100 channels to, you know, really fill the space in a way. And also this, it's very easy to set up and easy to control. So the macro controls I already mentioned. There's different layers in that. And also what is very important, I haven't said that the software is built in MaxMSP at the moment, so which is also something which is also kind of the strength of it, basically. So we started, as I said, we started to build a tool that we could ourselves use for live music, but then the tool got more and more like a framework software. So it's more a software that is in which you can implement your own software. So maybe that makes more sense to say it in another way. So it's, if you think about a mixer, and the software is really set up like a mixer, then you still have your aux channels, and you can plug in like a pedal board or an outboard effect, or hook up a synthesizer to the insert, you know. And the way the software is designed is that also for other users, it should be very easy to implement their own max patches, if it's a processing effect, if it's a spatialization idea, or if it's like a new kind of synthesizer that you have never seen before, or something like this. So there's when you know Max, you like know a little bit about it. There's a set of very small set of abstractions where you just put in one abstraction and automatically connects to the whole infrastructure with automatic like routing of channels and with automatic implementation of the MIDI mapping and so on. So yeah, that's the idea, to have it also expandable and to have it open for other people to implement their own ideas and to make it as complex as you want to, basically, in the end. Yeah, and yeah, among many other things, it's possible to switch the algorithm that we're using for the rendering per channel, which for us was really interesting to experiment with the different qualities of the algorithms and see like what kind of sounds they fit to and what, yeah, also use it as a sound design possibility, basically, in the end. Okay, now I will show you actually some concrete things. So for me it's very small now, but maybe you can see. So the software is kind of, there's two windows. When you open it, there's this window here. Sure, of course. So this is kind of the master window, where you have some master controls, like set up the speaker setup that you can change. This one is, as you see, it's the ZiMMT, but there's some other like predefined speaker setups, but you can easily also implement your own speaker setup. And it doesn't have to be of any particular shape, because you can switch the rendering algorithm. Of course, you have to use the one that is fitting to the kind of speaker layout that you have, but it's very open to different kind of multi-channel systems in that way. Then, of course, you have the possibility to listen binaurally. Then there's a master effect section that also allows you to implement kind of a master yeah, plugin. It could be it could just be an equalizer or something, but it could also be a complex routing system where you can like address multiple multi-channel systems at the same time, or yeah, do some other crazy things, maybe send some other channels outside of the software to some other renderer, or whatever you want to do, you can implement here. Then there's two reverbs that can be addressed as like aux reverbs, which is one is parametric reverb based on the parametric reverb from IRCAM, from the Spat library, which is generally like all the spatialization rendering is based on Spat in here. And convolution reverb, yeah, it looks a bit wonky, but I think it's like 7 years old or something. But it's quite wonderful because it has four, like at the moment it's limited to 4 channels, but at least it has 4 channels for like more spatial convolution reverberation. And it has some kind of nice, interesting tools like resampling, where you can just time stretch the impulse right in the software and manipulate this reverb also like in very creative ways. And another thing, yeah, of course you can record what you're doing. And one other button that I will click on later. But yeah, that's it. When you open it, and then you press a shortcut and create a yeah, secret shortcut. It will be in the tutorial when it's out, but you press a shortcut and then you open kind of one channel strip. And this is the idea. I can just add a few more. So in this way, it's really a mixer. So we have several channel strips now, like 4 channels. And some basic controls. In here, you see the spatialization surface from the top. So this is actually like looking from the top on the dome, as you're used to in many other softwares, I guess. Then you have a volume control filter that is both like a low cut and a high cut. So yeah, this is just one example for like an easy interface where we only need one knob basically to like have only super low frequencies or very high frequencies, and it's an expressive, really an expressive control that I use a lot. It seems very simple, but these small things, like they make you use it live. Yeah, and then you have like 2 aux sends for different reverbs, for the 2 different master reverbs. And yeah, then yeah, maybe I just go ahead and play a sound. So this is the first page. There's a second page. And this page shows all the effects and synthesizers and processing. So these are kind of in like a channel strip inserts. And we can change the order of the inserts, and then like the routing automatically adapts to it. I can show you a bit of that later. But right now I have an input patch. And yeah, it should play my sound. Volume is down. Does it come in the mixer? Yeah. Nope. I think it's too hot, this room. Yeah. Yeah. Okay, just give me a second. So the first fix was easy. The second one should be to... Ah, yeah, there we go. Much better. Maybe not for you, but for me. Okay, so now I have this. It's just a simple oscillator. It's one channel, so and this is the input patch that I set up with one channel. So you see one sound object here, and of course I can move it around by hand. Also move it up and down. And if you want to listen to the filter, that's it. At the moment it's VBAP, yeah. So in the third page you can go to settings, and yeah, that's the standardized setting that I personally prefer usually. Yeah, just give me a second. Yeah, so this panning here can be modulated with these kind of panning inserts. So the idea is that I can choose 3 different movement types from a list, from a dropdown, and just like a simple LFO, and just activate it here. And then in the second slot I can have like a Boyd's algorithm. That is right now doesn't really make sense because it's just one sound object. But here in the inserts now, my signal is coming in this input patch. And when I press on the insert, I can just insert like any kind of max patch or VSTs also. And these patches, they come with the software, but there's more patches that you can create yourself. And so the one I'm looking for, we should really tidy this up. Where is it gone? Okay, so that's already a bit too far, but so this one is an example for kind of how we can come from a very simple input, because we also use a lot of like analog gear that sometimes just has like one oscillator, or like like analog modular system. How we come from that to creating kind of a fusion also between the analog input and kind of the digital, like a simple analog input to kind of the digital possibilities of the sound design. So this is just some kind of pitch delay effect. And right now all the kind of voices of this effect, they are playing the same signal, but now we don't have only one signal anymore, but I can spread it around, and then you see it became 20 channels when I implemented the shifter, because the shifter uses 20 channels. That's what we found is good, like for the sound design that we want to do with it. And now all these 20 channels are playing the same kind of sound. They're all synced. But there's possibilities of, and this is just one idea for how we think like the processing in combination with this, with the spatialization. There's a possibility of decorrelating like all these 20 channels. So like setting a small offset to each single sound object, like in time, and by that creating kind of more kind of a mass. So if you listen to it. Okay, we give it a bit longer window size. So now I can just control this oscillator, but by that I can control like the whole kind of like sound mass, and it's already pretty. It's pretty simple, but it's already pretty powerful from like the sonic result. And they are all. It's a pitch delay, so now they're all on the same pitch, but can deviate like the pitch of each voice. So now they're kind of offsetted with a pitch like a super saw. Yeah, it's already pretty fun. Yeah, and then now we have this circular movement from this, like all this group of sound objects, but we can also move it around more freely with this Boyd's algorithm, for example. Yeah, so by adding these kind of ingredients of deviation per voice and different ways of like spatial expansion in the spatialization, it becomes like a complete spatial instrument, basically. So I want to show you another example for so this was some kind of processing thing that we're doing. Another example of synthesis engine. It's based on some kind of granular synthesis, but it's it's kind of our own take on it. So just load in some samples, and we can listen to it. Right now, just dial in some settings. I didn't prepare all of this because I thought it would be good for you to see that it's very easy to and stable, hopefully. So let's see. Okay. So yeah, some things are a bit laggy still. Yeah, so now I loaded the sample. It's some field recordings of ice plates in the winter. Maybe it's refreshing. And right now it's just one sound that is playing, just doing like regular playback. But all of these, like this one sound is actually consists of, I think 40 point sources. And all these 40 point sources are at the moment just playing the same signal. But again, we have this kind of deviation idea implemented here. And here you see how kind of the read head is running across the sound file. So that is actually what you hear. And I can tilt this line of read heads. And now it changes completely. But when I do this more extreme, then you see like in this line there's actually all these like 40 different sounds that are now offsetting, like reading this sound file with an offset, already creating this like huge texture. And you hear like, now we hear this rhythm that is kind of, everyone is doing it because it's a read head that is reading the sound file in a loop inside of another kind of window, which is set. But also this window I can deviate to create even more variety between the voices. And of course, for me it seems interesting that actually because the sound is not really moving, but just by adjusting kind of the order how the sound is read, we have some kind of special movement, you know? Yeah. And we can deviate not only the reading, but also the pitch of each tape head. Now you feel like the spatial movement is somehow connected to like a glissandi movement. And of course, they don't all have to read in the same speed. They can also read in different speeds, so they can just be scattered around on our sound file. Yeah, and that doesn't actually include any specialization right now, like any like traditional style specialization. So let's add this too. Okay, just one more example. So here I have a crackling sound. Okay, this is already spatial. Let's reduce it a bit. So it's just crackling. And then there's another process that is a resonator. And this one has 10 voices, and they all resonate in different frequencies if I want to. So that's kind of beautiful, and I can, just to show you, like right now I have 10 voices, but if I change the order of these two effects like this, then of course no resonation, but it automatically adapts to the 16 voices. So I really, until now I haven't thought about any like routing or like any matrix or whatever. Yeah, this is also nice to play it with like some outboard gear. So maybe at this. Okay, the software is great, but I didn't practice, so yeah. So what else? So yeah, then at some point we thought, okay, we also want to use like our favorite VSTs here, and as we used to work also like compose and work a lot in DAWs, we are always frustrated with the non-possibility of using like the good, amazing VSTs that we are so used to and that we like to use, and we can't use them on multi-channel signals. And we have a lot of multi-channel signals because that's how we create them, and then they're already like 32 channel or something like this, and then it's not so easy to actually process them. So in here, we can just select a VST from the list of installed ones. What is it? Q3. This is probably one that you all know. And so now we can just process this with the same GUI and the same VST, of course. Process it in here. We build like a small container that is automatically adapting to also again to like the channel count and so on. Yeah, so that's pretty neat. How much time do I have left? 3 minutes. Okay, that's not so much. Yeah, so just, well, there's a lot of things that we could that I could show you. Of course, we can change the algorithm, like I said. So maybe find another setting here. So now we're in ambisonics, but only on this channel. So this channel is still VBAP, of course. And so on. There's another thing that is still kind of in the making, but it's a clip launcher, because that's what we really missed in this environment, that we can just launch like fully prepared audio files, and they can be like mono, stereo, or any channel count, like 24 channel, 32 channel, or 100 channel, and then the channel automatically adapts to the file that is playing at the moment. So and it's it integrates directly with the Launchpad at the moment, so you can just hook it up, and then you have the layout kind of reflected from the software on the Launchpad, which is like also you don't have to think about any setup in this way. You just drag in an audio file like this one, for example, or maybe I should have used an empty track. Yeah, well, and then play it. But as I don't have any more time.
One thing I want to ask, can you show how you're dealing with parameter mapping and macro mapping?
Yeah, in the MIDI.
When you showed me first time, it was really
Yeah.
nice way.
Yeah, so parameter mapping, now I have just this MIDI controller, and I mean that's really simple to show. So I just move the button and press on any button, and then it's mapped. But the cool thing is that I can not only map like one control, but I can like map 3 controls at the same time, and then I can make a setting that I like being very loud and very reverberant, and copy the setting in the MIDI mapping as my like maximum, and do another setting, maybe with another reverb. And copy it as a minimum, just for the sake of the example. And now I can basically interpolate between these 2 presets, which was super fast and easy to set up, but now, I just have this like full control, and of course you can like map the spatialization together with the processing, together with everything. So that again makes like these kind of macros that you can think of combining like all these layers together. Another thing I think that Felix was referring to, this actually doesn't sound good, but so right now we're hearing these 10 voices reflecting, just push them a bit up, that are all set in different ways from this resonator. And we implemented a feature that connects the spatialization data, so the data about the position of the sound object, together with the setting of the synthesis or processing. So now I switched it on, and here I can define how these data sets are connected. So at the moment I have the spatialization y-axis on brightness and damping, but from the dropdown I can like select many more, and the idea is also to make it even more open in this way that also other things could be interconnected. But the idea is that now I can kind of move this I don't know if you can hear it. Yeah, sorry, maybe I should have prepared this. I think that's really the problem in it. But just for one last listen. So now we have basically spatially mapped zones that are connected to a certain sound timbre. So the space basically became timbre in a way. And I think Paul was showing something very similar with the Doppler effect that you were talking about, and connecting this to the delay kind of thing. And yeah, I think it's a very interesting idea to explore also. Yeah. Cool. Thanks a lot.